1, 2, 3, 4, 5. There is Google Kickstart round C starting in half a minute. I need to prepare my templates. I think there are test cases. That's templates. Remove everything else. Yes, save this. Done. Let's copy. Again, I will comment a little bit, but not a lot. Countdown. If this is exactly good number, then next plus plus. If next is equal 0, then answer plus plus, next is k again. It's done. Easy problem. Oh, I don't see what happens to 1, 0. Good. Let's not wait for the verdict and go with another problem. Is that brute force or not? Let's think. I think I can greedily check whatever letter I can add, and that should be it. Let's go with rows like that. In every column, taken. This is taken, then row plus plus. Now if something just takes a few next things, now for every next cell, if it's the same candidate, then it's bad, because it's also above. This is not what I should do. Let's do it differently. Here, every next thing is bad. So I don't even use the candidate. If but it must exist in a grid. For sure I'm implementing too much already. But it's only 6 minutes. Okay, it's not that bad. For every thing. So potentially. This is possible. Then this. Here I find the next block, and everything after that is marked as not okay. S is equal that this. I need to also sometimes put -1. But -7 somewhere I don't subtract a. Where? Maybe uppercase. This, that's uppercase. Damn it. What is N? Nice. Only uppercase? Yes, only uppercase. What about this? Wrong answer. No. I messed up. 201. It's correct here. Let's read the code. Something is wrong. Next expected is K. X. If it's next expected, then do this. else start from the beginning. Not always. I think that's correct. And for 3, 3, 3, 2, 1. Previously I didn't have correct answer here. That's bad. What about this? Accepted. Well, I'm behind. It isn't that bad. William is winning. Duel of YouTubers. Numbers are small. The sum will be 10 million. Can I say there are only 1000? I might get time limit exceeded. There are 3000 possible squares. It's this. I think it is fast enough. Problems are too easy today. I hope that William will mess something as well. Plus count of 0. Maybe let's first read that array. This will be a limit for values. Now let's create this of size like that. This is empty prefix. No. But just before that, for every power, 0, 1, and so on. Okay, let's find powers. Spref. Count of. I'm at this position and I want to get this. Done? It's quite easy to test this on max test. Test the speed. I will do that. But if it's too slow, I'm not sure what to do exactly. 139. Okay, and now instead of that, let's say a of I is 100. One test with n equal to this. Too slow. Maybe not too slow. 2.5 times 5. Oh, barely enough. What about what can I do? Is that pessimistic case? Yes, it is. Okay, I need to submit this. I just have no idea what I would do differently. Correct. Solved on, oh, I should have looked earlier. It means he got time limit exceeded. It will judge for quite some time. Let's read. Sweetness, operations. Update sweetness, query sweetness score of subarray. That's something extremely easy. Done. I can win this. I think I will win this. The last problem is quite a standard one. Just let's multiply every next element by -1. And then it's a simple arithmetic progression. Oh, the input is complicated. N and Q. Read an array. What about making it with indices from 1 to n? It will be a bit more convenient. Limit for values 100. So, but still I will need long longs. Let's make everything as long longs. Pref and pref arithmetic. If I modulo 2, then this. Every second number multiplied by -1. And now, I times A of I. And is it time to read query? There are updates. Oh, whoa. There are updates. So it is a segment tree. Right. There is sum and there is sum of arithmetic series. Let's also go with size. Function to merge. Size is end. This is shifted up. Okay. Will I have, no, everything will be iterative. This will be like base of a segment tree. Let's fill the leaves. A tree of b plus I. Of A of I. Actually, every leaf should have size equal to 1. Maybe it's not that important. Okay, now I'm ready for queries. U for update. And things are numbered from 1 to n. If it's U and value. Let's go with longs. I don't have time to think if they are necessary. Three of society. Okay, update should be done. Query L and R. Node, left. That's not right. This should represent something empty. Not single, left merge, left right. Not left, answer. Now we have answer. Why won't we print that? Sometimes multiplying by -1. Why did I print so much? Something is wrong with my reading. 5 and 4. I need to print the sum of values or what? Okay. Total. Whether I will win this contest depends on if I make some bugs here and how much time I will spend debugging. I got this. Nothing is lost. 9, 2 and 19. Cool, it's just about -1. Now first I think that depends on this. Done. Maybe that's enough. Maybe not. Oh, he already finished. accept. And by how much did I lose? By minute and a half. There was also eat more, also with one incorrect submission. So what did I mess up? Which problem was it? Countdown? Yes, the easiest one. The easiest one costed me a win. I wonder how much the place affects the number of views on YouTube. If you don't know, William Lin has a YouTube channel and he's now getting much bigger than me, I think. What can you do? Well, go watch his video as well. Itmore doesn't have a channel, but he's a very experienced competitive programmer. I hope I was recording. Yeah, I was. Just like a few words about every problem. In countdown, what I did is we count sequences like 5, 4, 3, 2, 1 for given k, the initial number. And I said that next, variable next represents that next number I'm expecting. If I get exactly that, then I'm expecting number smaller by 1. My answer was my mistake was that if I don't get an expected answer, I say, oh, this number is failed. But maybe I expected 3, but I just got 5, and this is beginning of new countdown sequence. I got wrong answer, for example, for test 3, 3, 2, 1. Because after initial 3, I expected 2. I didn't get that, and I didn't count that 3. Then there is stable wall. That was a boring problem, and I spent too much time for sure implementing that. Where there are some letters, and you can use a letter if it's only the prefix of some column, if it's not above some not taken letter. I thought that maybe we need some binary masks here, and DP on bit masks, or to create a graph that this letter must be taken before that letter. For example, I'm sure it's possible here to count the number of possible output strings. Perfect subarray. I was scared about limits. Again, I wasted half a minute testing that unnecessarily, because the sum of numbers is, this problem is very similar to subarray sum equals k. I have a video for that. Or subarray divisibility, also another recent video, where the subarray sum is equal to difference of two prefix sums. So we need to use prefix sums, and for one prefix sum you want to say the other one, if it's smaller by 9 than you, then the sum will be 9. And that means and that will be square. Also, the number of possible squares is not that big, because the sum of all numbers is 10 million. The possible square, there are 3,000 possible squares in that case. So my complexity is for every position to go over those 3,000 possible squares. So that's n times 3,000 per test. And that is barely fast enough. And can this, it's a standard but not easy segment tree problem. I multiplied every second number by -1 to simplify this sequence into 1, 2, 3, 4, 5. And then I use this trick. I think that's the only. Also, I now let me just draw that easily custom dark gray. What is that? This is CodeGem. Why is it open? Can this? Pop. If you have a sequence and you want to take numbers with multiple 1, 2, 3, 4, if there were no updates, this is quite standard problem to do, because you can pre-process that for every prefix of the array. So what's the prefix like that, 1, 2, 3, 4, 5, with those multipliers. First number times 1, second times 2, and so on. And then if you take this, subtract it from this, 1, 2, 3, 4. So subtract this prefix with multipliers up to that, minus up to this. As difference, you will get this sequence between with those multipliers, 5, 6, 7, 8, 9. And now to get what we want, we just need to subtract 4 from every number, multiplier 4. So I need to minus 4 times standard sum. And so we need two prefix sums. One is standard prefix sum for the sum of numbers, to know this, and the other is prefix sum with multipliers, like this. So prefix sum, I call this pref of a, where I sum up index I times a of I. And this is the sum of that. This is just the sum of a of I. Here you go, that's the trick. But we had updates, so I did the same in a segment tree. That also can be done. And I have a standard implementation of a segment tree. I was even lucky that I didn't make any big mistakes. Yeah. Everybody in top 3 made one mistake, one incorrect submission, and without that incorrect submission, that person would win. So we are 2 minutes apart. Well, congratulations to William. He is very good, and I wish him all the best also for Google Code Jam. He's so younger than me. When I was his age, I was so weaker. I'm sure in 1 year I will have no chance against him, but still we can compete. Maybe even tomorrow, there's Sunday evening. During some stream I want to do some 1v1 with him. We'll see that. You'll see that collaboration soon. Okay, thank you for watching. That was, I guess, pleasant 25 minutes. And just, of course, I'm angry at myself because of that incorrect submission for the first problem, because yes, that everything else was fine. Thank you for watching. Bye bye.